Hello everyone and welcome to this tutorial on how to use your GPU for AI tasks, including machine learning and deep learning, instead of relying on your CPU. Using a GPU can significantly accelerate computations, especially for deep learning models. Let's get started step by step. Create a new environment and install required packages. First, open the Anaconda prompt and create a new environment with TensorFlow GPU support. Use the following command: Anaconda create and name TF GPU 0 TensorFlow GPU. This will create a new environment, name it TF GPU 0 with the necessary TensorFlow GPU version installed. Process, we choose Y. Pages include CUDA toolkit with the version 11.3. It also includes CUDNN. The version is 8.2 and some other packages. Now it is done. To activate this environment, we can use conda activate TF GPU O. Now step 2 is activate the new environment. Activate the newly created environment by typing conda activate TF GPU O. This ensures all your installations and tasks are isolated to this environment. Step 3, install TensorFlow 2.10. TensorFlow 2.10 is compatible with many GPUs. Install it using Python pip install TensorFlow equal 2.10. Oh, successfully installed TensorFlow. Install the Jupyter kernel for this environment. To use this environment in Jupyter Notebook, run the following commands: pip install IPy kernel is installed, and we use the following command: Python IPy kernel install user name GPU O and display name Python TF This makes the TFGPUO environment available as a kernel in Jupyter Notebook. Step 5, open Jupyter Notebook. In the environment TFGPUO, write Jupyter Notebook. In kernel menu, select change kernel. Choose Python TFGPU. Step 6, verify GPU availability in Jupyter Notebook. To check if TensorFlow recognizes your GPU, run the following code. Import TensorFlow as TF. Now print GPU details, tf.config.list physical devices, GPU. TensorFlow found GPU and it is GPUO, device type GPU. Step 7, first example comparing CPU and GPU performance. Here's a simple example to compare the time taken for matrix multiplication on GPU and CPU. Import TensorFlow as TF, import time, check available GPU, then create large random matrix data, then perform matrix multiplication on GPU, print the time, and perform matrix multiplication on CPU. TensorFlow found GPU and matrix multiplication on GPU completed in 5.4 seconds, while matrix multiplication on CPU completed in 21 seconds. Step 8, second example, training a neural network using GPU. Importing necessary packages, unload MNIST dataset, normalize the dataset to the scale 0 to 1. Now build a simple neural network model and compile the model with the using Adam optimizer. Then train the model. We choose 10 epochs. Now evaluate the model on the test set. The test accuracy is 0.98. In this tutorial, we learned how to set up a GPU-enabled TensorFlow environment, verifying GPU usage, and perform computations using TensorFlow. We also compared GPU and CPU performance and trained a simple neural network using the GPU. By leveraging GPUs, you can significantly speed up your AI tasks and focus on building better models faster. Thank you for watching. See you in the next one.